So in the previous video, we looked at intervals and simple inequalities. And today we're going to look at compound inequalities and absolute value inequalities. So just a reminder of how to solve a compound inequality. These are the ones that you can describe using either and or. So an and inequality is going to be where the value you find is between two numbers. An or inequality is going to be where the solutions lie outside of two numbers, okay? So number 10 is an example of an and inequality. And we're going to treat this exactly the same way as a regular one-sided inequality, but essentially we have two equal signs when we solve this. So we're going to work from the inside out. So I look at 2x plus 1, and I know that I need to subtract 1. But I'm going to subtract 1 then from all three places. Okay. So that gives us now negative 4 less than, that didn't change, 2x less than 2. Lastly, we'll divide by positive 2 because we're trying to get x by itself. That's positive, so we don't need to change the signs. We get negative 2 is less than x is less than or equal to 1. So I feel like these are easier to translate to an interval because it's lower bound negative 2, upper bound 1. So we know that it's going to look like this. We just need to decide parentheses or brackets on the negative 2. Should be parentheses. Parentheses or brackets on the 1 should be brackets. And so to sketch the graph, that is going to be pretty straightforward, and it'll look just like this, okay? Now, if you do have to divide by a negative and it reverses your signs, so let's say that I started with something like negative 10 is less than or equal to negative 2x is less than or equal to 8, for example. If I divide by negative 2, that's going to reverse everything. 5 is now greater than or equal to x, greater than or equal to negative 4. That is fine, but in and inequality, we always list our answers from least to greatest. So if you end up with something like that, remember it should always go lower bound, upper bound. We need to reverse this. So now it says negative 4 is less than or equal to x, less than or equal to 5, which would be the interval negative 4 to 5. So just something to watch out for there with your compound inequalities. I'm going to skip number 11 because I think that you can probably do that one on your own. It's very similar. Number 12 is an or inequality. So when you have this, it's basically two separate inequalities that are describing two separate areas on the number line. So we solve them separately. So here we get 3x is greater than or equal to 15. So that means that x has to be greater than or equal to 5. Or on this side, we get 2x is less than or equal to 6. And so x is less than or equal to 3. Okay. Now, this has to be an or because those two things cannot be true at the same time. You can't be both greater than 3 or less than 3 at the same time. That describes two different sections on the graph. If we think of what that would look like, greater than or equal to 5 would be going this way, but less than or equal to 3 would be going the opposite direction. Now, it would be impossible to write one interval that shows both of those things. But since I, again, want to provide one solution set, the way that we show that these two sections are part of the same solution is that we use the union notation. So the lower section of solutions is negative infinity to positive 3, and we're going to say include with that, so union, from positive 5 to positive infinity. The union takes those two disjoint sets and combines them into a single set. We can't do anything with it from there because they don't overlap anywhere, but that union essentially implies that this is all one set of solutions. So that's how you will write your or inequalities, okay? Now, the compound inequalities are important because they translate to absolute value. So recall when we talked about absolute value before that absolute value represents a distance. So if I say that my distance, and this is how I like to remember it rather than memorizing rules. If you're a memorizer, that's fine. But to me, it's easier to get an understanding of what's actually happening and then know how to figure it out from there. So if I have something like the absolute value of U is less than C, what that is saying is that if I'm here at U and here's C and here's negative C, my distance from U needs to be less than that. So it could be anywhere between negative C and positive C. However, if I have this statement that says my distance must be greater than C, and I have U in the middle and either positive C or negative C on either side, if my goal is to get farther away from U, then I need to be walking towards the opposite directions. So the first case is going to be an and, that's a between type inequality. And the second case is going to be an or, which is going to be those two outside inequalities, okay? Remember that in the first case, we can write the answers using one interval, but in the second case, we're going to have two separate intervals that need to be unioned together. So let's look at a couple of different examples here. So for number 12, the absolute value of x minus 4 is less than 3. The absolute value is already by itself. That's great. So we need to now interpret this as a distance. This says distance is less than 3. So that tells me that my distance has to be between positive 3 and negative 3. And so we'll add 4 to both sides. We get 1 is less than x is less than 7. That's the interval from 1 to 7, open on both sides. And the graph would be 1 to 7 and everything in between. Okay? Number 13 is a little bit more work because we have to do some isolating of the absolute value just like before with the equations. So I'm going to start by subtracting 7. That gives me negative 2 times the absolute value of 3x plus 5 is less than or equal to negative 20. And then I need to divide by negative 2, which is going to flip my sign. The absolute value of 3 plus x, or 3x plus 5, is now greater than or equal to positive 10. Now my sentence says distance is more than 10. So that means I have to set up two separate inequalities. Again, if we're thinking about what this looks like, we're in the middle. If I'm at 10 and negative 10, my distance needs to be getting farther. I need to be walking away from those values. So we know that either 3x plus 5 has to be less than or equal to negative 10. That's this side of the inequality. Or 3x plus 5 has to be greater than or equal to positive 10. That's the right-hand side of the inequality. Either way, our distances need to be getting farther away. And so now we solve these individually. 3x is less than or equal to negative 15. So x is less than or equal to negative 5. Or 3x is greater than or equal to 5, and that means x is greater than or equal to 5/3. Now writing that as an interval, they don't overlap, so I have to use union to create a single solution set. So the first one can go from negative infinity up to negative 5. And we're going to union that with the second interval, which will start at positive 5/3 and go to positive infinity. And so our graph will look like negative 5 and then down through the negative infinity arrow. And then, whoops, that should be a bracket, sorry. And then 5/3 to the right and up through the positive infinity arrow. So there we go. So go ahead and pause the video, try the last two problems on your own, and come back in 3 seconds to check your answers. All right, here are the answers. Number 14 should have ended up as an or, and number 15, because you have to switch the sign, should end up as an and. And so those are your intervals and those are your graphs. So happy practicing, and let me know what questions you still have.